Hello and welcome today to our Würth Elektronik days and explanation about infrared and invisible technology. Today we are going to talk about what is infrared light, what are infrared detectors, what type of applications and technology we can do and what we can achieve. First, we will begin with just a simple explanation about our technology and what infrared is. Then we will go on with some information about the different applications and what you cannot do, where the drawbacks and the main issues. And we will continue with some fundamentals, present our Würth Elektronik infrared dream team and our products, and give you some insider on what are the next products that you can expect from us. First of all, what is infrared? Infrared is emission, optical emission, close to the visible range, close to the visible light that we see, but it's with a bit higher wavelength and our eyes cannot perceive it. The range of infrared is between 750 nanometers up to 10,000 nanometers, divided in three different groups: the near infrared A up to 1,400 nanometers, the mid infrared or ERB, which is between 1,400 to 3,000 nanometers, and the far infrared from 3,000 up to 10,000 nanometers. And of course, what is used for, if not for illumination or the eye cannot see it, basically the main use of infrared LEDs, because it's not absorbed or it doesn't decay that fast, is for fast data transfers and communications. And how do we achieve this? Actually, we use an infrared emitter and we couple it with different type of photodetectors or light detectors and use the invisible light as some data transfer. In our case, most photodetectors can be grouped into two different parts, the photodiode and phototransistor. A photodiode is basically a simple diode that has a light generation from light, or current generation from light. It has a relative low output signal, but it has a very fast response time. The other type of detector are the phototransistors, which is basically a normal transistor which has a gate with a photodetector. The benefits on this: you have an amplified light or signal output in higher current output, higher gain, but the drawback is you have a relative slow switching time or lower switching time. I will go back more about the different LEDs and diodes and transistors, but first of all, I would like to show some more about the different applications or where actually we can see infrared light in action, because as I said in the beginning, infrared light is unfortunately undetectable and invisible for the human eye. Main applications: maybe somebody thinks, okay, what is infrared? It's everywhere in our house. Who doesn't have a remote control for his TV or for his garage door or for his stereo? All this uses an infrared light emitter, which basically sends a signal to control your TV. And nowadays, you can also meet it in some modern vacuum cleaners. Basically, there you have the opportunity to scan your room, to get the surroundings, so your vacuum cleaner will go over the whole area and will clean the whole house. But what is important to use a remote control and a cleaning robot in this case? It's important also not only the infrared light, but to choose the right detector. In some cases, we can offer two different detectors with and without daylight filter. So if you imagine a vacuum cleaner working at home and just going to your stairs and coming back, going and coming back, or going over this sun rabbit or sunspot in your house and not be able to do it, it's because sunlight is very bad for the detectors. Sunlight has a very high intensity, and sometimes you need to use a detector with a daylight filter. As you see on the spectral sensitivity graph, the dashed and the solid red line, you see that the daylight filter can cut a lot of the intensity, the visible light. This means that your detector will be able to see more of the invisible light and detect better or achieve better signal to noise ratio. So this is a bit about how to use your infrared light at home. But infrared light you can also find outside in the free room. As for example, have you ever wondered why the door opens when I go inside or when I go in front of the door? Most of those doors have a detection or infrared emitter and detector that works on presence and detects people around him. And also here we face different challenges. How I'm going to construct my detection, what are the area that I'm going to detect. As for example, we can see that viewing angle or the light output distribution is a very important part here. If I create a wide beam coverage and shorter detection range, then only people in front of my door will get inside. But if I have a focused beam far away, then all the pedestrian on the door will open and close the door. Sometimes not the best option, especially in the winter, when you need to keep the door closed and open only when customers or people want to get inside. Of course, the viewing angle. We will go back to it later and explain in details what viewing angle is. But the next part is also the detection area or the intensity of my light. As you can see, if I use a very low intensity, then my covered area will be very small. So if a small person comes to the door or a kid comes to the door may not open. And in the same case, we need to find the perfect solution so the door doesn't open for only for dogs or for cats or for any home animals. These are basically the two main challenges for every supermarket, every hotel, every automated door in our case. But this is not only the case for automated doors. If you think about hygiene and automatic switches, all the disinfection, water siphons, and hand dryers in public and office washrooms, I think to 90%, all of them are now switching to some touchless devices where you have to think about the same application and the same problem like the doors or public doors. Only in this case, your hygiene articles or your water siphon will not use any touching. This means that no transfer of bacteria or germicides uh, in the washing room. As we know, washing rooms, due to their humidity and warmth, are basically the most potent source of spreading out different bacteria. So The same application that we have here can be applied everywhere with a single infrared emitter and detector and detection. But this is not the only health application about infrared products. As you can see, infrared LEDs and detectors, they can be used for different health monitoring. For example, here, all these pulse meters that can measure your blood pressure and blood pulse are based on a different LED and detector and the absorption or reflection of different blood cells in your blood vessels. How actually does it work? We at Würth Elektronik have made a simple application which everybody can make at home or everybody can find on our website and read about it. It's just a simple signal detection from your fingerprint, which you can put over an emitter and detector that work at the same time. What you need to do is drive your emitter and detect the signal from your photo detector. Of course, using some tricks from the Würth Elektronik portfolio, like different filters. For example, we need the low pass filter and the high pass filter because we all know in which range we can expect our heartbeat to be. And of course, we need to block the DC signal, and this way we can make a lot better signal. Of course, we need also some amplifier because the detection range in this case is a very low. Very simple. We can put the signal again after the filtering, after the physical filtering. We can put also the signal in a small microprocessor where we can do additional pulse calculation, filtering, some analog or some digital filtering at the end, sorry. And then we can get the signal from the microprocessors. And this one is like everybody can do at home device. Of course, we can also help you and support you in developing your own device, or you can read our application note and articles on this. But not only health is important. For example, we use different infrared light for different light barriers. How we get inside, or we can read different uh, traffic light signals or different signals from our number shield plates, or as example, our automated warehouse where we have the trails, the robots, which use different uh, deflection, refraction, and different counting methods to analyze their position on the rails, and this with speed up to 15 meter per second. And this is also in our top end warehouse. Everybody can see. But not only in the industry, the infrared light can make also your world safer, and you can find it everywhere in your house. For example, different smoke detectors which use diffusion of infrared light through the smoke can and are based on a simple emitter and detector. At the moment, very important because when you are sleeping, the smoke detector helps protect your house. As for example, in Germany, after making smoke detectors uh, for every house, a compulsory device, the problems and the incidents with people reduced more than 5% since the last 5 years. Another application, of course, the surveillance cameras and infrared devices where you can look at who is coming in your house, or you can protect your house when you are not at home and see who is coming day and night. But not only safety in the house, you can also build different light sensors and detectors, and you can use the application for different energy saving, for different uh, light and heat controls, for example. Uh, One example of this is when you have the sunlight coming into your house, you can always detect how much sun is coming and turn on and off your lights, turn on and off your shutters or blinds. And in this case, you can save energy by using more sunlight. And this can also be automated using ambient light sensors on different photodetectors. I guess I covered now more of the applications in this case and what different ways or way you can find your infrared LEDs. Now I would like to turn your attention more to the details and more on the products or how we can develop these products and what is important to know about the products. First of all, about the structure. Every structure or every emitter and detector has almost similar structure. It has a substrate and lead frame or housing, which shows what or how my detector looks like. A different chip, which is the active component and emits or detects light, and the optics or the encapsulation, mainly used for changing your viewing angle and protecting your chip. Now I would like to turn your attention on the different parameters that comes from this structure. First of all is the emitter. Emitters with the standard infrared light emitting technology have two wavelengths, 850 and 940 nanometers. We offer both of those standard wavelengths with all our packages, and I will show the different forms and pictures later. And the most important here, we provide the peak and centroid wavelength. The difference between them, the peak, as you see, is the maximum of your spectrum. But because your spectrum is not asymmetric, we can provide a centroid wavelength or the wavelength which gives you the mass of weight or the middle of your area of your spectrum. Also, we give the emission power of your LED. We can define two different power ranges, the one giving you the radiant intensity or the milliwatt per steradian value from 1 to 100 milliwatt per steradian depending on your viewing angle and the focus of your light, and high power LEDs which have a light intensity more than 300 milliwatt per steradian, mainly used for illumination, night vision cameras, and some gesture recognition where you need a very high resolution. The second most important parameter, this is the viewing angle. Viewing angle, as you can see here, can vary between 20 and 150 degrees and shows you how focused your light is. A 20 degrees viewing angle is very focused and 150 degrees is not that focused. Basically, main important parameter to choose when you want to see what is my active area. Then another important parameter is the switching of LEDs. Switching time is defined with the time to reach between 10 and 90% of my intensity. Our LEDs, most of them are qualified with very short rise and fall time of around 10 nanoseconds, and this measured between 10 and 90%. This means that you can use them in applications, in most cases 10 to 50 megahertz, depending on how fast you want to do it up to 100 megahertz, but then you need to make other consideration about your signal and information. Another important parameter here is when you use higher switch time, you need a higher current. With higher current, you also get a better intensity, higher intensity, better signal. But this comes out also with a trade-off, because I can pulse my LEDs at a higher current, but then I need longer time, or I need to use my LEDs to relax. This is like the duty cycle. As you can see on the curve, if I use a duty cycle of 50% or 50% of the time on, 50% off, I can reach a very low value of 2 amps. But if I decrease my duty cycle to 1% and 99% off and 1% on, I can reach even higher values. So this is something important which needs to be considered when using your LEDs in some highway post application. Now, those are the main parameters of the LEDs. And what are of the detectors? Detectors usually don't have an emission spectrum, but they have a range of spectral bandwidth, or in which area I can detect my LEDs. They can also be specified with a photocurrent, dark current, and the direction angle, at which direction or which angle I get my main parameters. Based on the different LEDs and the different detectors, we can also depend the photocurrent. Photocurrent is actually the measured value in each of your photodetectors, be this a photodiode or phototransistor. Photodiodes usually defined with a linear photocurrent dependency from the light illumination. On the other side, the phototransistor can be described with the collector emitter voltage and the collector current, or the current that is generated from the light. What's the main difference between a photodiode and phototransistor? As I said in the beginning, they have a few differences. Main difference: one has a photocurrent in microampere. The phototransistor, due to its gain and improvement, has a photocurrent of a few milliamperes. So you have a better signal to noise ratio, better detection range, and better resolution for different light intensities. On the other side, switching times of photodiodes range is nanosecond. Switching time of phototransistor is the microsecond. So depending on how fast you want to be your detector, you need to have a photodiode or a phototransistor as your main component. Now I would like to go on and start and present why we have our products, or what makes the infrared Dreamteam from Würth Elektronik with our infrared detector and emitter the best parts. We have chosen your parameters and our products in such a case that we have a perfect match in our detection range. As you can see here, the spectral sensitivity of a daylight filter to the 940 nanometer, the peak wavelength of both is 100% match. And on the other case, the peak detection range for the 850 nanometer and the detector without a daylight filter is 850 nanometer is 59%. So this is a very good conversion between your actual electrical or optical signal into an electrical signal. In one case you have 100%, in the second case you have 59% of your signal. We also have a very wide range of products. In our portfolio, you will find the best team, as you're going to find the matching size and form for each of the different emitter and detector, be it the PLCC type or THT, the through hole technology lamps, or a side view, a reverse mount, every kind of chiplet. And of course, you will get the best match and the fast switching times from our products. The single standard footprints we can also say that we have 99% of all the footprints available on the market, starting from the smallest 0402 to the high power 3535 ceramic. And our products are built with look into the excellent parameters on excellent material quality. We use gold plated contacts, we use gold wire. Our chips are pre-selected for a very small deviation between the product on the single reel and the single package, and we have an excellent encapsulation part. So when choosing Würth electronic product, you know that we have the best products. And of course, our wide range of applications that I mentioned in the beginning: night vision or security camera, home appliance devices, healthcare devices, identification, and so on and so on. What we can offer you further is our Würth electronic support. We have the application design kit, one with the order number 154150, which contains all our products or our full range of infrared LEDs and detectors, and it offers the lifetime refill of the products. And of course, our free of charge Red Expert tools, where you can find most of the electro-optical parameters that are available in the datasheet. But if you have any further questions, you can always contact your sales representative and get in touch with the product management. We can offer further ray files and different uh, pose measurements and different type of measurements for your application. Just ask your sales representative for further help. Now, I hope that you have a nice overview of our products and why your electronic products, as we stand for our quality. Now, I would like to take a short time to introduce you our infrared portfolio. We have a general portfolio of infrared, ultraviolet, and all type of signal, general lighting, and horticulture LEDs. So if you wonder what type of LED you want to do or want to have, just drop in on our website and you have the best choice of products. And as the topic is more about infrared LEDs, I would like to present you some of the most common tips of our LEDs, namely the chip type LEDs or the small chip LEDs used for some near range application and some detection for different machines or inside some machines. We have every industry standard package ranging from 0402 to 1206 with all the wavelengths 850 and 940 and top view, side view, and reverse mount products, and able to provide you different viewing angle between 20 and 150 degrees. Furthermore, we have the standard PLCC type LED, the high power LED with typical driving currents of 1 amp and pulse capability up to a few amps. our through-hole technology LED, you can ever be sure that you will find them with us, and standard wavelengths and output powers. What is new this year is the through-hole technology with a smoked lens, so you don't see the detection. Unfortunately, not given in the presentation, but soon to be available on our website. The same counts for our photodiodes. We offer the same chip LEDs and side view LEDs and through-hole technologies with and without daylight filter and with high photosensitivity and in almost every standard industry package. The same range given for our phototransistor chip types with side view, top view, reverse mount, with and without a daylight filter. And of course, the PLCC types and through-hole technology types, again, industry standard package with and without daylight filter. But with this, I would like just to let you know whenever you have any questions or some inquiries about different packages, please don't hesitate to contact us. We can always work and introduce you some new packages or work on specific projects with you and provide the best performance and the best parts that you are going to need. At this point, I would like to end up my presentation, but not really end up and only show you a few of what are you going to expect in the next few months from us. We have the next part for everybody that doesn't know German, and let's put it this way, we are a company based in Germany, and unfortunately our team didn't have the time to present everything in English. Please excuse me, but the brand new parts we offer at the moment our optocouplers. These are opto-isolators with a phototransistor output. As you can see on the schematics, on the one side we have the anode and the cathode, and on the second side, on the second part, we have the collector and emitter. This is nothing else than getting an infrared emitter and infrared detector, putting them into the same package, so they have their transmission ratio, which is also predefined, but now used for different applications. The main functions in this case, this is the isolation of different electrical systems from over voltages, from voltage spikes, and isolation of different persons from dangerous electrical devices. If you can think about in all of our power chargers or phone chargers or mobile chargers or laptop chargers, we have a transformator that is used to transform your high current to 220 volts into 5 to 20 volt charging voltage for your device. But you also need the feedback from your charging device, how this is working or when I have to shut down. Most of these cases, optocoupler helps and divides the two parts and gives you the nice feedback to your main charging circle. Please, if you inquire further information about optocouplers, also contact your sales representative, and we'll be happy to provide you more information. Optocouplers will be available on our website, and you can order first samples free of charge and test your application and see how our optocouplers are working. With this, I would like to thank you for your attention, and I hope that I could bring you some more information or inside view about the working of infrared LEDs. And please let me know if you have any questions. You can always contact us on our hotlines and give us more feedback. Thanks a lot and have a nice day.